In this video, we're going to perform the center of gravity method using Python. To access the worksheet that we're working on, go to drstephpowers.github.io/mgmt-in-python. So if you go here, you'll find the workbooks for operations management, and we are going to be looking at location planning. Here we're going to be using the center of gravity method. So what you want to do first is you want to click on the link here, and we're going to open it in Google Colab. In order to work through this workbook, you will need to make sure that you have logged into your own Google Drive and that you save a copy to your drive so that you can edit and run the code. And I'm just going to minimize this one since I have one here where I am already logged in and a copy saved. And the first thing we're going to do is we are going to import pandas as PD and import numpy as NP. So we will need pandas in order to build our data frame that's going to have our longitude and latitude. We're going to need numpy in order to manipulate that. So to build the center of gravity, we're going to need something to lay out on our graph. So in the center of gravity method, when we were doing it by hand, we overlaid a grid and we decided 1, 2, 3, 4, 1, 2, 3, 4 vertical, the X and Y axes in order to create that grid. Well, if you're going to overlay it on a map, you already have numbers. Those are longitude and latitude. So we can collect the longitude and latitude for different locations, and then that will serve as our grid. And the great thing is that's already laid on top of a map. We don't have to draw vertical and horizontal lines with numbers on top of the map like we do if we're not doing it in Python. So what we need is we need some longitude and latitude. Well, if you go to Google Maps, and here in this example, what we're doing is we are collecting longitude and latitude for the different McDonald's locations in Red Deer, Alberta. So what you would do is we could search McDonald's. It would show the locations in McDonald's. And if you right click, you can collect the longitude and latitude here by simply, we right clicked, and then we can click here on that longitude and latitude. It copies it to the clipboard. And then if I'm doing this inside of Python, I can simply paste that. Now I would do that for each location. So you can see in the code below, I've said data frame, we're going to name DF is equal to, and then we have put parentheses around each of those locations. So here is one McDonald's, then we would do open comma, open parentheses, we go in and we collect the next one. And we would paste that one in, and we'd repeat the process for all the different locations we're considering with our center of gravity method. So that's how I got this line of code here. It is simply all those different locations, each one pasted from the longitude and latitude provided by Google Maps. And then the key here is that we've given it a name, df equals. And so then what we can do once we've done that, we no longer need this one where I have just started it, we can run that in. And so what we're going to do is we're going to take this information and we're going to use pandas to convert it into a data frame where the columns are latitude and longitude. So I'm going to run that, and just to see what that looks like, you can see here that we have a column called latitude and a column called longitude from that data we put in from all of our different McDonald's locations. Now, the first thing we want to do is plot those locations. So we want to essentially create our own version of the Google Maps that you see here that has the different locations we're looking at. So to do that, we're going to use the package called folium. So let's import folium. And then we need to specify that our latitude and longitude are float, that the type of information we're providing is float, which means that we can have decimals. So of course our longitude and latitude are not whole numbers, they're not integers. They are float, they can have lots of different decimals. So we're going to do that conversion, make sure it knows that longitude and latitude have the type float. And then using folium, we are going to create a map And we want that map to be centered on the average of the latitudes and the average of the longitudes. We can specify the zoom level. Okay, so the bigger the number, the more zoomed in, and you can specify the type of tiles. How do you want your map to look in terms of that underlying look? Do you want it to look more like to show the roads? Do you want it to show more of the terrain? There are different types of tiles you can use. So when we do this, we then are going to take this map we have just created and we're going to populate the map with markers. We are going to loop through our table, our DF. We're going to iterate through the rows. Now, in our table here, we have index, and so we are going to look at each particular location, and we'll go through each of the indexes, and we're essentially going through the rows, right? Each row in this table is a different location. So we are going to iterate through those rows based on that index and row and create a marker. These markers are going to be circular markers where they are going to put essentially a circle where we have the latitude and the longitude, and we could specify how big the circles are by changing the radius. What we're going to do is loop through all of those different rows and each time add the marker to our map. So we run that, and then when you call your map, which we called M in the previous code, what we end up with is a map that looks like this. So here we have 5 different McDonald's in the city of Red Deer. Now this is an interactive map, so I can scroll and zoom in or I can zoom out. So if you didn't choose the right level of zoom in your initial map, you can change it after the fact by zooming in and out of the image. So what we see at a glance is we see there are 5 McDonald's, and we're trying to decide where to put our distribution center. So perhaps each of these different McDonald's locations have the same supplier, and so the supplier is going to be going to all of these locations. They're trying to decide where should we be located. Well, with the center of gravity method, we can look at these 5 locations and say, okay, if we are going to send equal amounts of supplies to all 5 locations, then the best location is the one that's going to be essentially, equal distance from all these different 5 locations. We can also use the center of gravity method where we weight the location by how much materials go to a particular location, in which case we would want to put our distribution center closer to where more of the materials are going to have to be distributed. So let's look at how to do this. Let's start with equal shipments. So what we're going to do is we're going to add a second marker to our graph. Again, we are using the original graph M. We are using the package folium. We are adding a circle marker, and we are going to have that location this time be labeled green with a radius of 4. So let's make it a little bit bigger. I think that's bigger than what we had previous. I think we were at a radius 2, yeah. Oh, you can't see that because my head's covering it up. Radius 2 originally. Let's make a bigger dot. We'll make it radius 4. We're going to make it a different color green so it stands out. If we are doing equal shipments to all locations, then your ideal location is just going to be the average of the longitude and latitude. So we would take that column of latitudes and find the mean or average. We take that column of longitudes and find the average. And all we're doing is putting a green marker onto the map at that location. So I run that, I update our map, and you can see here this bigger green. It says that if I am going to be distributing to these 5 McDonald's locations and I'm sending equal shipments to all of them, then it really makes sense that my distribution center is going to be right in the center so that I have to travel equidistance, spend the same amount of gas and time to get to all 5 McDonald's locations. Now, what if we have one particular location that needs a lot more supplies? In which case it would make sense for that distribution center to be closer to that location because of the more frequent deliveries or the bigger shipments would save money on gas and time. So to do that here, we would need to add a column to our table that represents the amount of goods that are being sent to each location. So I've just written some numbers in here. So we're going to add to our table DF a column called goods. And we're going to have 50 go to the first location, 7 to the next, then 3, then 42, and the last location is 99. Okay, so if I run this and then I output my table, you can see that it is the same table as before, but we've added the column goods. Now what we're going to do is find the weighted average of the longitude and latitude. So before we were just finding the average. Now we're going to find the weighted average, weighted by the amount of goods going to each location. So I'm going to call this weighted average latitude. I'm going to use numpy, NP, to find the average. And we're going to find the average of the latitude column, but we're going to weight it by the goods column. Okay, so we do this calculation. We can see the weighted average latitude. Repeat the process where we find the weighted average longitude. So again, we're using numpy to find the average of the column called long, and we're going to weight it based on the amount of goods. And when we do that, we get the weighted average longitude. Now you can repeat your process of adding this to the graph. So we are going to use the folium package. We're going to add a circle marker. The key here is that the new location is going to be our weighted average latitude and our weighted average longitude. And well, let's make it a different color so that we can see the difference. So let's make this one red. Again, we'll make it a little bit bigger than the McDonald's locations, which were radius 2. Let's make this radius 4 so it stands out. And so we run this, and then we call our map. And what we can see here when we load this is you can see here was the original location in green if we had equal amounts going to each location. Now what you see here with the red is you can see that it is shifted based on the fact that we had one location where we had 99 goods going. That's double the next amount, substantially more than the other locations, right? If you go back to our original data here, we had a 42 and a 50, but this one was 99. Others are 3 and 7. So it makes sense the distribution center would be further away from the location here in index 1 and the location here in index 2, and it should be closest to the location that's listed here in index 4, which is what we see here on the graph. So it should be closer to the ones that have more goods. And so we can use the center of gravity method to help us decide where to locate our shipment or distribution centers based on the companies that we are supplying materials to. So here you can make it in Python as opposed to having to do it by hand. So notice how a lot of the calculation is automated through your Python code, which means now all you have to do, if you're doing this for your own data set, is you would simply need to have your longitude and latitude for the locations that you are considering. And then you need to have, if we are weighting it based on the amount of goods, you need to create a column for your goods. And then you just run the code through and it'll generate the same graph based on your location and the amount of goods that are being distributed.